All right, so what you should be is on your computer. I would like you to page on page 94. In your ISM book, you should have put in your reading, practice, and your Newton wheel for today. This should be on that page. So let's look and see what we have to have written on that page. So toward the back of the reading, it talked about Newton's law, first law, and it was the first law of inertia. What does that mean? First law of inertia.
Object at rest on state rest.
Unless acted on by an outside force, right? Perfect. And then it told us Newton's second law, which is acceleration equals force net. And remember yesterday when we were drawing all those vectors that we were doing yesterday, and we were finding the net force? That's what goes on top, divided by the mass, okay? In our I can statement is you should be able to compare velocity and acceleration. So, velocity is on this side, acceleration is on that side. So, they both include vectors, right? So they're the same. So that's not going to be on a Venn, unless it was a Venn diagram where you had the center, right? But this is a T-chart comparison. Displacement and velocity. Is that different? Yes. Distance, time, and direction of motion. Velocity and time. Time is the same, but everything else is different, correct? Okay? Displacement divided by time, velocity divided by time. Those are different. Meters per second squared, seconds is different, right? And then V equals D divided by T, and A equals V divided by T. Do you have that written down in your ISM book? So when you come in during the daytime, you come in, you answer your question of the day, and then if Miss Sloan ever has anything written on the board, make sure you copy that in your notes because those are important. The only thing we have left is we just have to do the problems next. So that is where we're going to now. In your book, I think they're in 95 or 96. We'll give you a minute to write that down. Y'all have the top written down. I'll erase the blue. So if you have a question on your test this week that compares velocity and acceleration, you should be able to use this T-chart to kind of help you out on what you can answer. Okay, let's turn in our book to page number 96. And we are going to do the sample problems. Remember, I never make you do the challenging one. I just make you do the ones that are not. So the very first one says, two horizontal forces, 225 newtons and 165 newtons, are exerted on a canoe. If these forces are applied at the same direction, find the net horizontal force of the canoe. So the first thing I'm going to do on my paper is I'm going to draw my canoe. Now it tells me two external forces, but it don't tell me if it's a push, pull, or what. So you can do your vectors anywhere you want. So remember, this is your system. Water, everything else is not what you're including. And it says that it has a force of 165 and another force of 225. Okay, so what do you think we're going to do to these? Add them together because they're both going in the same direction, right? So it would be 225 plus 165. I want you on your computer, open up your calculator that we did the other day. And I want to see you use the calculator to get your answer, please. So remember, it's the little bunny that's on your calculator. Open your main screen. Just downsize this and go to your main screen. Thanks, sir. See the little bunny? Open him up. Okay, and you're going to go to the second one, enable scan, please. Thanks, sir. There's your calculator. So now it's going to be, and what we're going to do is we're going to have it stuck here. So open it up and attach it to that bar, please. So if you right-click it, it should attach it to the bar always. So what I want you to do is turn your calculator on. Go to 225 plus 165. I want to make sure you understand how to use it. Fantastic. And you're exactly right. Now, I want you to take that answer and I want to change it to scientific notation. So let's go to mode on our calculator, please. Mode on our calculator. Mode on our calculator. Hit that. There we go. Change it to scientific instead of normal. Okay. Change it to scientific, which is the next one. Click it. Okay. All right. Get out of the mode. Click your mode again. Okay. Yep. You can go anything you want. There we go. Now do second answer. So you do the blue and then the answer down at the bottom. Second answer and hit enter. And let's see what answer we get this time. Okay? That's the number I want you to write down. Get ready to do that? Okay, so go to mode, go to scientific, hit enter. Okay? And it's fine, you're good. So just go ahead and then do second. Oh, clear. Clear is fine. Now do second. And down here where it says answer. And then hit enter. Write that down. Okay. Was everybody successful on getting the scientific number?
Yeah.
Fantastic. So did you get 3.90 times 10 to the second power? Perfect. Write that down. This is an exercise on using our calculators today.
I did not get that.
Okay. Can I borrow? Okay. 165, that's why. That's all I wanted to know. I'm sorry, did I get you?
No, you.
Okay. The second one says what? Says the same forces are on both sides, opposite direction. So I got my canoe again. There's my system. What's my numbers?
225 and 165.
Same thing as what before. Okay? So this time, I'm going to do them this way. Because to me, it makes sense, right? So this would be force applied. What would be going back? Force friction, correct. Okay? And I just made those up. Force applied on the canoe by the motor, right? Force friction on the canoe by the water. That's what I'm going to say happened. So if I have that, what am I going to do now? 225 and 165. What am I going to do?
You're going to subtract them.
Subtract them, okay? 225, subtract 165, and keep it in scientific notation. Yep. 6 times 10 to the first power, right? What you got, Freddie? You didn't nail it. No, you're fine. Oh, no, that's 225. You're fine. So, if we're doing that, now, based on my diagram, which direction is it going?
It's still going forward.
It's going then, okay, so it's going in a larger force. So this direction is going to be a larger force. And did you get 6.0 times 10 to the negative power? 6.0 times 10 to the first power. And it could be negative or positive, depending on which way it is. Okay? Now, since it's going left, Freddie, what is it? The answer.
Oh, the answer is -1?
Negative 6.0 times 10 to the first power. Perfect. Because it's going to be going in the opposite direction of what it was. Yeah. Okay? Questions about those two problems? Okay? Let's go to the next page. So on the next page, we have two people, right? Fighting over a pillowcase. You have Sarah and you have, the girl's name is A for me. So it says A is holding a pillow with a mass of 30 kilograms while Sarah decides that she wants it and tries to pull it away. If Sarah's horizontal on the pillow is a force of 10 newtons and A pulls on a horizontal force of 11 newtons, what is the horizontal acceleration of the pillow? So the first thing they did was the force diagram. Do you agree with the force diagram?
Yes.
Okay. Why is there a net force going toward A in a positive direction?
Because she's pulling harder.
Because she's pulling harder. Because she's pulling 11 compared to 10, right? You see how they annotated it there? You need to make sure you understand how they annotated it. Then they go and say the mass is 0.30 because it tells us, right? It tells us the force of A is 11 newtons and force of Sarah is 10. So we're trying to find the net force. So we're going to take A plus the negative number of Sarah. But what they're doing is they're using the second law, which is acceleration equals force net divided by mass. And the only thing they did was just take the two numbers and do it. In your calculator, I want you to do that. So this is what I want in your calculator. I want 11 subtract 10 over 0.30 kilograms. How do we do that in our calculator?
Okay. 11 subtract 10 and then.
No. We're doing it all in one. Are you ready to follow? Okay. So you're going to do alpha y enter. Do you see that on your calculator? Alpha y and enter. And it should show you a fraction. Alpha y enter. And you got your fraction. So now what I want you to do is I want you to do 11 minus 1, 11 minus 10. I want you to use this arrow button over here on the right. That'll take you down to the bottom. And then I want you to put 0.30 in here. And hit enter. What did you get?
3.3 continuing.
3.3 continuing. Did everybody get that? Okay? What does the book say? The book says 3.3 meters per second squared. We're all good, aren't we? Another exercise in the calculator. Let's look at question number 9. A spring scale is used to exert a net force of 2.7 newtons on a cart. If the cart mass is 0.64 kilometers, what is the car's acceleration? So, what do we want to write down as far as our information? What is our net force?
2.7.
Okay, 2.7 newtons is our net force. Okay, we got our mass, right? What's our mass of our car?
Is 0.64 kilograms.
Perfect.
Yeah.
And what are we looking for?
Acceleration.
Acceleration. What formula are we going to use?
The F net over N.
Correct. Okay. So this is our second law we're using. So we're going to go 2.7 newtons divided by 0.64 kilograms. All right. Alpha y equals, to get our fraction, and put 2.7, arrow over to 0.64, please. And tell me what you get. And I'll come see it. You show me.
21875
Mm-hmm.
times 10 to the 0.
Yep. You're working on yours. You got yours yet? You got yours? Okay. Okay, so, yep. 164. Yep. Okay, and then, there you go. That's the answer you get. Questions about number 9? Questions about how to use the calculator? This is Newton's second law we're using, right? Let's look at number 10. What variables do we know in number 10?
Her acceleration and her mass.
Okay. So number 10 says Katrina's learning how to ice skate. She wants her mother to just pull her along so she can accelerate at 0.80 meters per second. If her mass is 27.2, what is the force that is needed? So what are we going to do? F net equals M times A, right? We changed the formula. Remember? Okay. So what is her mass?
27.2 kilograms.
Okay. And we're going to time that by our acceleration. What's her acceleration?
0.80.
Yep, 0.80 meters per second squared. Put it in your calculator, and you should get 22 newtons. Yes, sir, you do.
Can I put my charger in the one of these hours?
Sure can. Did you get it in your calculator? And guys, I think that since it's a touchscreen, I think you can actually physically touch the calculator up there.
No. Wait. Huh?
No, that's so sad.
Hmm.
I was hoping since it's touchscreen, we could do that.
No, you can't.
Nope, you can't. They lied to me.
Wait.
Did you get 22 newtons? Oh, you're doing it, Frank?
You can touch your calculator?
He's touching his. Fantastic.
How you do
I don't know. Is there a setting?
that? I don't wonder.
We'll pull down the settings and see what they got. Okay. Questions about the practice problems, because that's the end of that. Everybody good with that? Stop the video, because that's all we need to know about that.